So today we are looking into the application of the antidifferentiation to kinematics. Kinematics means motion. So when you were learning differentiation, you learned that if we have x as a function of time, x position, then how we were finding the velocity, the function, how velocity
X times
changes.
t. No.
What's the relation between velocity?
y2 minus y1.
The gradients.
Gradient, so derivative.
I think it's the gradient.
So velocity is the derivative of the position. Now acceleration, derivative of the velocity, yes. Now we will be able to do the opposite. If we know acceleration, we can find the velocity and we can find the position. So, if we know how velocity change over the time, then velocity, if acceleration is derivative of velocity, then velocity is antiderivative of the acceleration. So we need to find antiderivative of the acceleration. And when we will find, we will have plus c. So we need to know velocity at certain time to find the exact function for the velocity. And position, because velocity is the derivative of the position function. So then position we can find as antiderivative of the velocity function. So when you're going from position to acceleration through velocity, we differentiate. When we're going from acceleration to velocity and position, we antidifferentiate. And let's consider this on the example. Let's consider that stone is thrown from the cliff with a height of,
100.
let's say,
50.
50 meters, thrown vertically up with the initial velocity
5.
equal 20 meters per second. That's what we have.
We got some potential energy.
Also, what we know,
The
one thing, acceleration, because the acceleration due to the gravity is g, and it's down, and we, for simplicity's sake, we'll take it not 9.8, we'll take 10 meters per second squared.
There's some easy
No.
physics stuff that I failed.
So, we know acceleration is constant, equals 10. Down, we choose up as positive. Let's choose position x up, positive, so acceleration will be negative 10. Then velocity, we find an antiderivative of negative 10 dt. We take negative 10 out, we get antiderivative dt. What is the antiderivative of dt?
X.
No, if it dx will be x, if dt will be t. So you'll get minus 10t plus c. How we can find c?
Sub in.
We use that at time equal 0, velocity is 20. So we have 20 equal negative, negative 10 times 0
Yeah, plus it.
plus c, so c equals 20. So we have expression for velocity equals 20 minus 10t. Makes sense how we got the expression for velocity.
Yeah.
How do you find A? Is A because
Because it is acceleration due to the gravity,
but
and
the
everything that
stone
you...
doesn't have mass.
If it will not have mass,
Yeah, I know.
the gravity will not act on it, and it will not have acceleration.
Shouldn't it be mass times gravity, mg?
That will be force, not acceleration. Okay, it looks like you're going to fail physics.
It's fine, I'll trigger you.
So, let's find position.
I'm getting that lead.
Now, position is antiderivative of the velocity. So, equal antiderivative of 20 minus 10t dt equal antiderivative of 20 dt minus antiderivative of 10t dt equal, what will be this equal?
20t.
20t, yes,
I don't get that.
And then
because we take 20 out and we will have again derivative, antiderivative of dt, it's just t, because t in the power of 0. What will be this antiderivative equal?
5t squared.
5t squared. Because we take 10 out, we get 10 antiderivative of t in the power 1 dt equals 10 times power plus 1 t squared over 2 will be equal 5t squared minus 5t squared, because 10 over 2 is 10 plus c. How we can find c?
sub is
time.
When time equals 0, x equals 50. So let's substitute it there. So we have 50 equal, these both will be equal when substitute take t equals 0, so c equals 50, and expression for the position equal, x equal minus 5t squared plus 10t plus 50. That will give us position at any given time. Now let's answer a couple more questions. First, how long it will take stone to hit the ground at the bottom of the hill?
X equals 0.
X equals 0. We take x equals 0 and we will get quadratic equation. We'll get minus 5t squared plus 10t plus 50 equals 0. Simplify, divide everything by negative 5. Remember, always make squared term positive. That will minimize your chances to make mistake.
Can you do it without doing it, taking out 5? Like how, I feel
You
like,
can, but it will be much more likely to get it wrong.
yeah, but like,
So we have t squared
nobody usually
minus
uses, like,
2t
factors of 5. I'm not arguing.
minus 10 equals 0.
5 times.
And this one does not have two numbers. It does not,
Quadratic
we can
formula.
factorize it to the whole number, so we need to use quadratic formula. T equal negative b, so 2 plus minus square root of b squared 4 minus 4ac, so plus 40
Over 2.
over 2 equal 2 plus minus square root of it will be 2 root of 11 plus minus 2 root 11 over 2. Which solution we need to keep, which one we need to reject?
Keep positive, reject the negative.
Because time cannot be negative. So we have time will be equal 2 plus 2 root 11 over 2 can be simplified to 1 plus root 11.
Wait, can you do it the other way now? Because wouldn't it be easier to do it the other way?
What do you mean by other way?
When instead of doing the quadratic formula, like from negative 5t squared, take out the negative 5 and 50 to find
That's what we did?
10.
So he means like the grouping method.
I mean, like,
That doesn't work.
It will not work because we don't get, we can complete the square,
yeah, complete the square.
we can complete the square, yes.
Then you can
From
find the,
here, reminding completing the square, that will be t minus 1 squared minus 1 minus 10 equals 0. T minus 1 squared will be equal 11. So t minus 1 will be equal plus minus root 11. T equal 1 plus root 11. Yes, we can do completing the square. Or quadratic formula. Whatever you prefer. 1 plus root 11 is probably, check with your calculator. I will estimate it as about will be 4.2.
8.
I guess 4.3.
4.28.
4.3.
Oh,
Okay. 4.3.
4.32.
So 4.3 seconds. Now next question. What will be the maximum height that stone will reach?
Find the
It's actually hard.
What we need to do?
Yeah.
turning point.
Turning point. Turning point means velocity
0.
equals 0. So velocity, formula for the velocity was v equals 20 minus 10t. We equalize it to 0. We get t equals 2 seconds. And then we substitute this time into our expression for the height, where for x equal, we had minus 5t squared, minus 5t squared, what was that, plus 10t, plus 50, plus 50. We substitute 2, we get minus 20, plus 20, plus, no, something. Is 2 times 2, 2 squared 4 than 20, plus 20 plus 20 plus, okay, let's check this, something, is that formula was minus 5t squared plus,
Yeah, I was
sorry, plus 20t,
Ah.
it is plus 20t, velocity 20, yeah, so it
The other
will
one's
be,
wrong.
huh?
We did plus 10 on the other one.
On which one?
On the
To find the 2 seconds.
to find 4.3 seconds. We did plus
5
10.
point through?
I'm pretty sure.
No.
Yeah, because we said 2 and 10. If it was
5.
No, we did, I think we did,
We did 10.
we did 10.
Yeah.
So if we, with this one we divide by 5, yeah, if we divide this by negative 5, then x will be equal t squared minus 4t
plus
and
10.
minus 4t minus 10. Yeah, and then if we complete the square, t minus 2 squared, t minus 2 squared minus 4 minus 10, we have t minus 2 squared equals 14, t equals, will be t equals 2 plus root 14.
Yeah.
2 plus root 14, so that will be, root 14 will be about 3, will be 3.6, about 3.6, about 5.6. Check with the calculator. 5.7 seconds. So time equal 5.7 seconds. Okay. So we substitute, but this is still correct because formula for velocity was this. And substituting here, we get minus 20 plus 40 plus 50. We get the maximum height 70 meters. Now, another question. What will be the total displacement of the stone?
Oh,
Uh,
the underneath the graph.
Negative 50.
It was initial position was 50, final 0. What the displacement? Negative 50. So you got displacement.
Isn't it the area underneath the graph?
What is the graph?
You could make the graph.
Yeah, we can sketch this graph and find area under the graph, and we will get with sine area, but sine area we will learn next lesson. Now,
I'm ahead
what
of you
will be
guys.
the total distance?
Benjamin, did you hear that?
What will be the total distance?
140.
70. No, 90.
Highest, it went from 50 to
9.
70.
So
Move 20 up
Yeah,
and then 70 down. 20
Wait, what did you say?
plus 70
Don't worry about
That's a.
equal 90 meters.
That's my table for
How can you throw a ball 20 meters into the air?
it. It's
Pretty
not the
easy.
gravitational potential.
Good.
Now,
20 meters. That's a lot.
what will be its average velocity? How we find average velocity?
The gradient.
No, gradient give us
Yeah.
instantaneous.
Rate of change.
Speed over time.
Average velocity is displacement over time. So velocity average will be equal displacement negative 50 divided by the total time 5.7.
It's around 8.36.
Which
Really?
What?
I'd say around
If I get that
negative
right.
8.6.
Wait, I said 8.6. Huh?
will be negative
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 8.7.
8.8.
Oh, I was close.
8.8 meters per second.
Actually,
Now, what will be the average speed? To average speed,
Distance
we need divide distance over time. So it will be 90
over 5.
over the same time, 5.7.
I would estimate around
15.8.
16.8, I'd say.
15.8.
Was it?
Yeah.
I got that right.
15.8
Yeah, you didn't say
equals
I said
15.8
15.8. Did I
seconds.
say
You
16?
said 16.
I said.
And speed cannot be negative, it's always positive. Okay,
This is a scalar.
I can't remember.
that's
Check.
all new for today.
Very nice.
Thank you.
Go.